We're supposed to list all the numbers that makes this fraction undefined. Notice, just instinctively, factoring everything first is not a good way to go. What makes a fraction undefined is when there's a 0 in the denominator and something else in the numerator. It could be anything, like a 7 or 11 or perhaps even a 0. So what we want to find out is what makes the denominator 0. In other words, when will this denominator be 0? Now, to solve this equation, we could use the quadratic formula, but my strategy is to factor if factoring seems easy and use the quadratic formula if it doesn't. And since 2 is prime, I'm pretty sure that it's going to be 2t and t. Now I'm going to use 6's and 1's to try to make 11, or 3's and 2's to try to make 11, and I don't really know, but I think that a 6 and a negative 1 is going to work. I think I can see it coming. If I put a plus 6 here and a negative 1 here, let's see if that in fact checks. 2t times t is 2t squared, negative 1 times 6 is negative 6. 12t, take away 1t is 11t. So 2t minus 1 can equal 0, or t plus 6 can equal 0. How do I know? Well, I have two quantities multiplying together to give 0. So either this first one has to equal 0, or the t plus 6 has to equal 0. I'm not going to show the individual things that I'm doing to both sides. I added 1 to both sides. I divided both sides by 2. Now that we're in Math 89, you can show your work without necessarily showing what you did to both sides always. Here I'm going to take away 6 from both sides and have t equals negative 6. So it looks like there are two numbers, t equals 1/2 and t equals negative 6, that make the denominator 0 and therefore make this fraction undefined. Here we're asked to simplify this fraction, and that requires us to factor the top and the bottom completely and then cancel any like factors. We would never try to cancel the two a squareds because a squared is not a factor. It's not being multiplied by the rest of the numerator, and neither is this a squared. And so we're going to factor, which is a skill we learned in a previous class, but we also practiced it in Chapter 5. This is the difference of two perfect squares, so it's going to be an a times an a and a 3 times a 3. But since this is negative, it's going to be a plus and a minus. Now we're hoping for one of these two because we're hoping for some canceling. And with an a squared and a 3 and everything positive, I'm thinking that probably there's going to be an a plus a 3. Now this has to be an a, and this has to be a 1 for the factoring to work. You can check that. But 3a plus 1a is 4a, and 3 times 1 is 3. So this checks. Now these are like factors, top and bottom, one from each, and they cancel. Notice these a's are not factors. A minus 3 is the complete factor in the numerator. So we can't cancel the a's, and we're left with just a minus 3 over a plus 1, and we stop there. It's important to know when to stop. Again, we're asked to simplify this fraction, which means factoring top and bottom and canceling all like factors. I'm going to start with the top because I notice that this is 2x times 2x, and this is 3 times 3, and that this is a minus sign. So I'm hoping that this is, in fact, a perfect square. 2x, 2x, 3, 3. And since we have a negative middle term, I'm suspecting that both of those will be negative. Now let's check it out. We've got minus 6x minus 6x minus 12x. It checks. Here I'm not sure. I don't know if the 10x squared is going to be 10x times x or 5x times 2x. I'm not sure if this is 6 times 1 or 2 times 3. But I'm going to make an educated guess that one of these two has to be in the denominator as well. So I'm simply guessing that this trinomial factors into 2x minus 3 times something. And it's easy to see what that something has to be. 2x times something gives you the 10x squared, so that'll be 5x. And negative 3 times something gives you the negative 6. That'll be plus 2. Now that's a guess. It's a good guess, but it's a guess. If this is going to cancel at all, this is going to work. So let's see. We've got negative 15x's here, and we've got positive 4x's here, and that's negative 11x's. and everything else works. This is 10x squared and this is minus 6. So this does work. We can cancel the like factors. We don't cancel anything else, of course. You've got to cancel an entire factor, nothing at all. And that's a pretty fast way to do this problem, because that denominator is pretty hard to factor. There are many ways to simplify this, but I'd like us to understand some things. First of all, we need to be able to easily decide whether the top and the bottom are opposites. So the question of whether the top and the bottom are opposites can be answered this way. If we take the top and we add the bottom to it, do we get 0? If we get 0, then they're opposites. So a minus x plus an x, that cancels to 0. And a 10 plus a negative 10, that cancels to 0. So these, in fact, add up to 0, and any two things that add up to 0 are opposites. Now, opposites cancel to negative 1, always. For instance, if we used numbers, 3 and negative 3 are opposites. Do you see that they would cancel to negative 1? 7, negative 7 and 7 are opposites. They add up to 0. Do you see that they cancel to negative 1? So a person who understands those things just looks at this and says, well, this simplifies to negative 1, and they're done. Can you do other steps? Yes, you can. For instance, books and teachers and people and things like that sometimes say, well, let's factor a negative 1 out of, for instance, the top. And then let's notice that negative 10 plus x is the same thing as x plus negative 10. And then let's notice that x plus negative 10 is another name for x minus 10. And then we have two like factors canceling, and there's your negative 1. Well, that's all very fine and good. And if we were math majors, we would probably care a lot. But the truth is, if you recognize these two as opposites, when you divide opposites, you get negative 1. And I think that's the main idea.